In this lesson, we are going to look at making conjectures, and this is done through inductive reasoning. We're going to use reasoning to make some predictions. A conjecture is a testable expression that is based on available evidence but is not yet proved. All right, so your evidence allows you to make the conjecture, but it's not necessarily proved for every possible situation. Inductive reasoning is drawing a general conclusion by observing patterns and identifying properties in specific examples. We want to make a conjecture about the product of two odd integers. And we want to support our conjecture with at least 3 pieces of evidence. So we need to make sure we understand what this is saying. Product is what happens when you multiply together 2 numbers. So we're multiplying 2 numbers, but more specifically, we're multiplying odd integers. Integers are any positive or negative whole number, and odd numbers are numbers that are not divisible by 2. So for example, -7, -5, -3, -1, 1, 3, 5, 7, etc. Those are odd integers. So if you think about what happens when you multiply 2 of these numbers together, what could you say is going to happen? What do you think is going to happen every time? Well, maybe you've decided that my conjecture is that the product of 2 odd integers is an odd integer. And I'm able to make that conjecture because when I look at these and I think to myself, well, if I multiply 3 times 5, I get 15. If I multiply 3 times 7, I get 21. -5 times -11 is 55. Those are all odd numbers. So I'm thinking that I can't think right off the top of my head where it wouldn't work, so I'm going to make this conjecture. Now I'm going to test this or support it with at least 3 pieces of evidence. Now when you're doing pieces of evidence, it's best if you don't just pick 3 types of evidence that are fairly similar to each other. Maybe I test it with a positive and a positive, with a negative and a negative, and with 1 negative and 1 positive. And I use a variety of sizes of numbers. So maybe I test it with 3 times 7. Both of those are odd, and I get 21. That's still odd. Maybe I decide to test it now with -5 and -31, sorry. -5 and -31 is going to be 155. That is odd. Good. Maybe I test it with -211 and +17. That's -3,587. Still an odd number. The more pieces of evidence you have that are a variety of different size numbers and that still show it to be true just simply strengthens your conjecture. It doesn't prove that it's true every time, but it strengthens your conjecture. If you were to use in your evidence one where it isn't an odd number, automatically your conjecture is not true. We want to make a conjecture about the difference between consecutive perfect squares. Again, it's making sure we understand the terminology. Consecutive means one right after the other. Perfect squares are numbers like 1, 4, 9, 16, 25, 36, etc. They are what happens when you take whole numbers and you square them. Difference is what happens when you subtract them. So what we want to do, if we take 2 consecutive perfect squares, so say 4 and 9, and we subtract them, we would get 5. We want to make a conjecture about what we think will occur every time. So maybe you're sitting there looking at this and you go, my conjecture is that the difference between consecutive perfect squares is always a prime number. And I get this because I tested some evidence and I went, okay, yeah, 4 minus 1 is 3. 16 minus 9 is 5. 9 minus 4, 16 minus 9 is 7. 9 minus 4 is 5. So I'm looking at that and I'm going, yep, those are all prime numbers. So I'm thinking that my conjecture is going to be true. Now, some of you might be thinking, well, I don't know if that's true all the time. And we're actually going to deal with that in the next lesson. So for right now, we made a conjecture. We used 3 pieces of evidence, which is the minimum that we want to use. And it looks like it's true. Is there more than one conjecture that could be made? Actually, yes, there is. Some of you might have thought of a different conjecture. Maybe some of you thought that my conjecture is that the difference is always an odd number. Okay, and we're going to test this with some data. We can use, well, we've got 36 minus 25, that's 11. We can use 16 minus 9 is 7. If we want to go even higher, if we used 100 squared and subtracted 99 squared, we would end up with 199. All of those are odd numbers. How is it possible to have 2 different conjectures about the same situation? Well, that's one thing about numbers, is sometimes there's more than one pattern to them. All right, so it is possible that you may come up with a different conjecture. We're not proving these. We haven't proved that our conjecture is true all of the time. So maybe one of those conjectures is also a false conjecture. The evidence that we've supplied shows that they are the same, but it doesn't mean that they are true all the time. We would have to prove them to know. So inductive reasoning involves looking at specific examples. So we're not looking at a general case. We're looking at a specific example. By observing patterns and identifying properties in these examples, you may be able to make a general conclusion, which you can state as a conjecture. A conjecture is based on the evidence you have gathered. The more support you have for a conjecture strengthens it, but it does not prove it. So you would have to prove it to know that it was true in all cases.